Delphi chassis ABS6. With its separate controller, GM service technicians have many years' experience with this system. But now there's a new system, Delphi Brake Control 7, offering advanced technology and robust dependability. This Certified Plus training video presentation is designed to examine this new system. After a short introduction, components and operation will be covered, followed by diagnosis and service. Several key aspects of the DBC7 system parallel the previous Delphi chassis ABS6. Throughout this presentation, we will highlight these items. With DBC7, hydraulic control uses solenoids and a pump. With Delphi chassis ABS6, this was done with ball screws and a motor pack. DBC7 uses an integrated controller. The ABS6 controller was separate. With DBC7, traction control can be integrated into the unit. ABS6 required a separate modulator. DBC7 is also smaller, with less mass than ABS6. Finally, DBC7 does have pedal feedback during an ABS event. Consumer research has shown that this is a desirable characteristic for drivers. The DBC7 system will be used on several models throughout the near future. Planned coverage through 2001 includes 1999 Buick Regal, Century, and Chevrolet Tracker. In 2000, there's a Chevrolet Monte Carlo, Impala, and LTZ, Malibu, Venture, and Cavalier, the Pontiac Transport and Sunfire, and the Oldsmobile Cutlass and Silhouette. In 2001, DBC7 is found on Pontiac Grand Am and Oldsmobile Alero. As with any ABS design, the objectives of the DBC7 ABS are: first, to maintain stability on split coefficient surfaces. Second, to improve steerability, since steering with locked front wheels is nearly impossible. And third, to minimize stopping distances. The objectives of DBC7 traction control are also familiar. First, traction control improves acceleration performance on split coefficient surfaces. And secondly, it also maintains stability during acceleration by limiting torque steer on front-wheel drive models. The speed sensors are similar to those found on ABS6 designs, with one at each wheel. On domestic front-wheel drive vehicles, integral speed sensors are used. With an integral design, the sensor and exciter ring are inside of the wheel bearing and are not usually serviceable separately. On the tracker, discrete sensors are used front and rear. With a discrete design, the sensor and exciter ring are two separate components. The exciter rings are located on the front rotors and the rear axle shafts. Typically, high-flex wire from the body to the sensor is used to resist wire breakage due to suspension movement. The normally open brake switch closes when the brake pedal is depressed. This switch sends a signal to the controller that the vehicle is braking. For DBC7, however, a brake switch input is not required to enter into ABS on domestic models. It was designed so a faulty brake switch does not eliminate the availability of ABS. Furthermore, brake switch adjustment problems will not affect ABS. However, note that DBC7 traction control, when equipped, will cease when the brake switch is closed. The system controller is mounted directly to the brake pressure modulator valve, or BPMV, under the vehicle's hood near the master cylinder. When the vehicle is equipped with ABS only, the controller is known as the Electronic Brake Control Module, or EBCM. When the vehicle also has traction control, the unit is known as an Electronic Brake Traction Control Module, or EBTCM. The EBTCM uses a microprocessor control algorithm to process inputs and control the BPMV. The controller is serviceable and incorporates a diagnostic algorithm to monitor system operation. The electronic brake control relay provides a shutdown capability during system failure. On DBC 7, it is integrated into the EBTCM. With ABS 6, this relay was a separate component. The BPMV executes commands from the controller. The master cylinder front outlet connects through the BPMV to both front channels. The master cylinder's rear outlet connects through the BPMV to the rear channels. On passenger cars, the 4 BPMV outlets go to the wheel cylinders through brake lines. When equipped, inline proportioning valves are used at both rear lines. Inside the BPMV, there are several components for hydraulic control. Solenoid-controlled inlet and outlet valves for each individual wheel cylinder channel. 2 accumulators, one for the front channels and one for the rears. A pump operated by a DC electric motor provides pressure for both the front and rear channels. When equipped with TCS, there are TCS valves for each front channel. The amber ABS warning lamp is located on the instrument panel. It illuminates if an ABS malfunction is current or if the EBTCM loses power or ground. The controller holds the warning lamp off during normal operation. The red brake warning lamp illuminates when the park brake is engaged, if there is a low brake fluid level, or if an ABS malfunction is present, which may degrade the dynamic rear proportioning function. We'll cover this later in the presentation. The ETS, or low track lamp, is on vehicles with traction control functions and may be amber or blue in color. It will illuminate during a traction control event. On tracker, the EBCM BPMV assembly is also under hood, just outboard of the master cylinder. Please note that the tracker has a 3-channel system compared to the 4-channel system found on front-wheel drive passenger cars. While the system-related lamps on tracker vary from the domestic vehicles, they are located in the instrument panel cluster as you would expect. However, tracker does have several unique components. The first is the longitudinal accelerometer located inside the parking brake lever bezel. The longitudinal accelerometer provides vehicle motion input to the controller. The 4-wheel drive switch is also an input to help minimize stress to the drivetrain. All speed sensor outputs are component values to calculate a reference velocity. When the controller sees one or more wheels approach lockup, ABS is activated to optimize brake pressure at the affected wheel. An alternating current, or AC sine wave, is generated when a tooth from the exciter ring passes by the sensor's pole piece, causing a magnetic flux change. The EBTCM calculates wheel speed by counting transitions in the sine wave. Increased sine wave frequency equals increased wheel speed. The sine wave remains AC with DBC 7. With Delphi chassis ABS 6, this was converted to DC. The EBTCM turns on the electronic brake control relay to provide a power feed to all system solenoids. The EBTCM can control each channel in a repeating 3-mode cycle: pressure hold, pressure decrease, and pressure increase based on input from the speed sensors. During non-ABS braking, the inlet valve solenoid for each channel is electrically off and hydraulically open. Each outlet valve is also off electrically but hydraulically closed. During pressure hold, the controlled channel inlet valve solenoid is electrically on and hydraulically closed, while the outlet valve solenoid is electrically off and hydraulically closed. This stops any pressure increase in the brake channel from the master cylinder. During pressure decrease, the inlet solenoid remains on and closed, while the outlet valve solenoid is now electrically on and hydraulically open. The EBTCM operates the pump to decrease fluid in the channel, thereby reducing pressure. During pressure increase, the inlet valve solenoid becomes electrically off and hydraulically open. The outlet valve solenoid is now shut off and hydraulically closed. At this point, full brake pressure from the master cylinder goes to the wheel cylinder. This process repeats over and over again until wheel slip is equalized at all channels. When equipped, the Smart Cluster operates the ABS warning lamp using Class 2 serial data through the Data Link Splice Pack. The cluster illuminates the amber ABS warning lamp when a message is received from the EBTCM or when it loses the state of health message from the EBTCM. Specific conditions are a detected system malfunction, loss of EBTCM power or ground, or an open or short in the Class 2 data line. Using the DBC7 ABS, dynamic rear proportioning, known as DRP, is included on Century and Regal. This eliminates the need for mechanical proportioning valves. As the vehicle slows down in a non-ABS stop, the EBTCM monitors front and rear wheel speeds. If deceleration at the rear wheels becomes slightly greater than the front wheels, the dynamic proportioning algorithm in the EBTCM activates to pulse the rear wheels until speeds equalize. On Tracker, there are 3 additional inputs. One is 4-wheel drive switch status, which is sent to the EBCM. The ABS system must change its braking algorithm during 4-wheel drive to help minimize stress to the drivetrain. Second, the longitudinal accelerometer is also a discrete input to the EBCM on Tracker. When voltage from the sensor goes high, the system decreases front brake pressure to limit front-end diving. Third, the controller uses the PCM to increase engine idle speed during an ABS event to decrease engine braking. Engine braking on icy surfaces can reduce ABS effectiveness. With the Enhanced Traction System, or ETS, the EBTCM monitors the front wheel speeds for positive slip. If positive slip exceeds preset limits, the EBTCM sends a message to the PCM to reduce torque to the front wheels. The PCM may reduce torque to the front wheels by spark retard, engine cylinder cutout, lean air-fuel ratio, or a transmission upshift. The following items will disable ETS: the ETS switch, if equipped, or various PCM ABS codes set as current. The amber ETS off warning lamp illuminates when ETS is disabled. The low track lamp illuminates when ETS is active. A traction control system with brake intervention is optional on the Regal GS. However, base brakes and ABS take precedence over traction control via thermal modeling and brake switch input. Although TCS is always enabled when the vehicle is started, it can be turned off by pressing the TCS Enable-Disable switch. The EBTCM monitors the front wheel speeds for positive slip. If positive slip exceeds preset limits, the EBTCM sends a message to the PCM to reduce torque to the front wheels. This can be done with spark retard, engine cylinder cutout, or a lean air-fuel ratio. The PCM sends a message back to the EBTCM indicating what percentage the front wheel torque was reduced. If necessary, the EBTCM commands the BPMV to apply brake pressure to reduce the remaining excess torque. During TCS brake intervention, the inlet valves prevent hydraulic pressure from being applied to the non-drive wheels. The TCS valves open to allow fluid to the pump for brake application. The following items will disable TCS. Brake switch inputs, thermal modeling, loss of communication with the PCM, any wheel speed codes, as well as all modulator codes. The TCS warning lamp illuminates when TCS is disabled. The low track lamp illuminates when TCS is active. Diagnosis on Delphi Brake Control 7 parallels what you've learned on other anti-lock and traction control systems, including ABS 6. DBC 7 initialization occurs at vehicle startup to check for proper system performance. During key-on static initialization, the warning lamps are illuminated for a few seconds and then turned off. The solenoids are commanded on and off, as is the pump motor. The EBTCM looks for proper component operation and does a self-check of its internal circuits. Dynamic initialization occurs at approximately 10 miles per hour if the vehicle is started with the brake pedal depressed. In these cases, the driver may notice pedal movement if the brake pedal is depressed and a loss of deceleration if moving down a sloped driveway with the brake pedal depressed. While strategy-based diagnostics directly apply to DBC7, it is important to review the diagnostic system check, as it is the place to start when clues and symptoms are not obvious. The diagnostic system check begins with determining whether scan tool communications are possible with the DBC7 controller. If communications are not possible, diagnosis focuses on the Class 2 data link and included controllers. However, when communications do exist, the scan tool's automated test within the Special Functions menu is used to operate the complete DBC7 system and its components. During this functional test, as well as normal vehicle operation, the EBTCM constantly monitors the ABS system and will set a DTC if the system is operating outside of preset operating limits. DBC7 DTCs are similar to those for other anti-lock systems. If a DTC sets, the ABS warning lamp will illuminate and ABS will be disabled for the remainder of the drive cycle. Note that an ABS drive cycle occurs if the modulator initializes or if a DTC sets as current during an ignition cycle. The red brake warning lamp will also illuminate if there is a possibility that the ABS malfunction may affect dynamic rear proportioning when equipped. If the malfunction is no longer present, the code will become history only and the warning lamp will not illuminate. However, realize that enhanced DTC information is still available. This includes ignition cycles and diagnostic criteria. If no current DTCs are present, the system check continues with warning lamp operation. If the lamps and their circuits are good, the check asks to look for any history codes. A road test is included to see if any history codes can be reset as current. At this point, diagnostics concentrate on speed sensor DTCs or a system-related intermittent. When diagnosing the system, realize that DBC7 data parameters directly parallel those you've seen on other anti-lock systems for years. The available functional tests are familiar as well. You can test the solenoids as well as the system relay. A DTC may be cleared with a scan tool if the malfunction is no longer present. However, DTCs will be automatically cleared from history if no code set for a number of key or drive cycles based on application. On a final diagnostic note, circuit testing requires that the J39700-99 controller adapter cable is used with the J39700 universal pinout box. The DTC diagnostic tables in the service information call out the necessary pin numbers for all required circuit checks. All base brake and ABS components are matched to the vehicle. Therefore, parts from other vehicle systems should never be used on a different vehicle. The EBTCM can be serviced separately from the EBTCM BPMV assembly. All solenoid coils and the relay are serviced as part of the EBTCM. The solenoid valves, as well as the pump, are serviced as part of the BPMV. The seal between the EBTCM and BPMV is integral to the controller. Be sure it is not damaged, as it helps prevent moisture from entering the assembly. For EBTCM removal, you must first turn the ignition switch to the off position. Never connect or disconnect the wiring harness connection from the EBTCM with the ignition switch in the on position. To begin to remove the EBTCM, disengage the Connector Position Assurance, or CPA, and push down on the tab. Then disconnect the harness connector by sliding the latch over. Remove the 4 EBTCM to BPMV screws and discard them. Then separate the EBTCM from the modulator valve by gently pulling them apart. Remember to be careful not to damage the seal. Therefore, do not pry them apart using any kind of tool. Also, be careful not to damage the solenoid coils when the EBTCM is removed from the BPMV. When installing a new EBTCM, first clean the gasket surface with alcohol using a clean rag. With the controller joined to the BPMV, tighten the top 4 mounting screws to specification in an X pattern. Now connect the EBTCM harness connector and push down the CPA to lock the connector in place. Turn the ignition switch to the on position. However, do not start the engine. Now the ABS diagnostic system check can be performed. When servicing the brake pressure modulator valve, always use extreme caution. The modulator must not be repaired. The complete unit must be replaced. With the exception of the EBTCM, no screws may be loosened. If any of the screws are loosened, it will not be possible to get the brake circuits leak tight and personal injury may result. As with EBTCM removal, always start the BPMV removal procedure with the ignition switch in the off position. Begin removal by pushing the CPA and the tab on the EBTCM harness connector. Then slide it over to disconnect it. Now disconnect the wheel cylinder brake pipes from the BPMV. On domestic models, the lines are color-coded. Next, disconnect the master cylinder brake pipes from the BPMV. Then remove the 4 bolts on the bottom of the BPMV that connect it to the bracket. Remove the BPMV and the EBTCM as an assembly from the vehicle. Remove the EBTCM if replacing the BPMV only, using the removal procedure specific for the EBTCM. When installing the BPMV, use extreme caution and make sure that the brake pipes are correctly connected to the brake pressure modulator valve. Follow the color-coded labeling. If the brake pipes are switched by mistake, wheel lockup will occur and personal injury may result. The only 2 ways this condition can be detected are by using a scan tool or by doing an anti-lock stop. Now, connect the EBTCM harness connector and push down the CPA. Turn the ignition switch to the on position and again do not start the engine. Now the ABS diagnostic system check can be performed. DBC7 uses an automated bleed procedure. Beyond the typical equipment, this requires a scan tool and a 35 psi pressure bleeder with an appropriate master cylinder adapter. A base brake system bleed is all that is required for typical component replacement. However, the automated procedure must be performed when the modulator is replaced, there has been an extreme loss of fluid, air ingestion into the system is suspected, or a base brake bleed does not result in desired pedal height or feel. Before beginning, be sure the battery is fully charged. Using a scan tool, ensure any DTCs are repaired before beginning. Also, inspect the system for any visual damage and leaks. With the vehicle raised and the ignition off, connect the pressure bleeding tool according to the manufacturer's instructions. Place the ignition in on with the engine off. Remove the tires as necessary. Be sure all bleeder screws are closed and pressurize the tool to 35 psi. Now the automated bleed procedure can be selected on the scan tool. Follow all screen instructions carefully. The scan tool cycles the pump and release valves for 1 minute. When cycling stops, the scan tool enters a cool down mode. The display counts down this time period. When complete, the scan tool asks you to bleed at each wheel. During this step, the pump runs and the respective release valve cycles for 1 minute. This is repeated at each wheel. The scan tool automated procedure repeats the process at each wheel. During the second pass, the automated cycle lasts 20 seconds to purge any remaining air. The scan tool screen identifies when the procedure is complete. Then relieve pressure at the bleed tool and remove it from the system. Inside the vehicle, gauge pedal height to determine whether the bleed was effective. Also, road test the vehicle to ensure the brake pedal remains high and firm. Realize also that on a vehicle with TCS, those valves are included and cycled during the automated bleed procedure as well. For system introduction, the only serviceable DBC7 components are the EBCM, EBTCM, BPM-V, speed sensors, and associated harnesses. If additional service is permitted, a service bulletin will be issued. Delphi chassis ABS6 has been standard equipment for many years on many cars. But now there's a new system, Delphi Brake Control 7, offering advanced technology and robust dependability. Our customers need to know that GM Service can handle this new system with the same high levels of expertise they've experienced for years. Dedicate yourself to being a DBC7 expert in the eyes of every customer. To earn attendance and completion credit for this course, take the test found in the accompanying course book and phone in your answers. After viewing the video and reading the course booklet, find the course test at the end of the booklet in section Q. To take the test, use a blank piece of paper. Record your Social Security number and the course number on the paper, along with the question numbers and answers to the test. In this way, you'll have everything handy when you place the call. Once you have completed the test, dial 1-800-446-8724 to receive your credit. The system will prompt you to enter your Social Security number. Use the keypad on a touch-tone phone for each of the digits. Then press the pound key. The system will repeat the number it receives. To verify this number, press the pound key again. Next, enter the numeric portion of the course number for the test you're taking, followed by the pound sign. Do not attempt to enter the decimal point or any letters. The system will then prompt you to enter your test answers. The system will not read the test questions. You will be prompted with a question number. If your answer is A, press number 1. If the answer is B, press number 2. If your answer is C, press number 3. And if your answer is D, press number 4. continue answering the questions as the system prompts you. After you've answered all questions, the system will repeat the questions along with your answers. If they are correct, verify them by pressing the pound key. If you want to change an answer, press the star key. You'll be asked which answers you want to change. This phone-in test procedure replaces the previously used mail-in procedure. In fact, you can use this phone-in procedure for all existing as well as future CPT courses. With this phone-in system, your test results are immediately entered into the Service Training Management System database, known as the STEMS database. The system will also give you immediate test results on how well you did. If you are successful, course completion certificates are mailed within 3 to 4 weeks. Study the CPT materials carefully before taking the test. Good luck.